In this video, we'll be taking a look at the following problem. A ball is thrown into the air with an upward velocity of 12 feet per second. The equation for the ball's height h at any time t is h of t is equal to negative 4t squared plus 12t plus 5. So there's three parts to this question. A, find the maximum height attained by the ball. B, find the time at which the ball reaches the ground. And C, find the time or times at which the ball reaches a height of 10 feet. For these type of problems dealing with projectile motion, I find that it's very helpful to draw some sort of picture or graph that models the ball's motion. So here's our graph. We have the x-axis representing the time the ball has been in the air in seconds, and the y-axis representing the height of the ball in feet. Now, the equation that models the ball's motion, h of t equals negative 4t squared plus 12t plus 5, is a quadratic equation, so the trajectory of the ball will be a parabola. Now, in terms of whether the parabola will open upward or downward, we just need to look at the coefficient of the t squared term. The coefficient is negative, it's negative 4, and so the parabola that models the ball's motion will open downward. And if we just think about it, we're throwing the ball up into the air, so it reaches some sort of maximum height, and then due to gravity, it falls back down to the earth. So it goes up and then it goes down. Alright, now let's get to part A. We need to find the maximum height attained by the ball. From looking at our picture, we can see that the maximum height is roughly here. And as you might guess, that point is the vertex of the parabola. Since for parabolas that open downward, the vertex is at the maximum value. So if we can find the x-coordinate of the vertex of this parabola, we can plug that in to our equation for h of t and find the maximum height attained by the ball. Now, I've made an in-depth video on parabolas and all you need to know about them in the past, and I'll have that video linked in the top right of the screen right now. But what's relevant from that video to this part of the problem is that the x-coordinate for the vertex of a parabola is equal to minus b over 2a, where b and a come from the general form of a parabola, which is y equals ax squared plus bx plus c. Now for the general form here, the dependent variable is x, but in our case it's t, but t and x for both these equations are interchangeable. So if we begin matching up terms, we can see that b, which is the coefficient for the x term, is 12 for this equation, and a, which is the coefficient for the x squared term, is negative 4. And so the x-coordinate for the vertex will be minus 12 over 2 times a, which is negative 4. And so we have negative 12 over negative 8, which simplifies to 3 over 2. But we have to be careful here. 3 over 2 is not the maximum height attained by the ball. 3 over 2 is the time at which, or the x-coordinate at which, the ball attains its maximum height. So now what we have to do is plug in 3 over 2 into our equation for h of t, and the value we get back will be the maximum height attained by the ball. So if we do that, h of 3 over 2 equals negative 4 times 3 over 2 squared, which is 9 over 4, plus 12 times 3 over 2 plus 5. The 4 in the numerator and the 4 in the denominator will cancel. So what we have is negative 9 plus 12 times 3, which is 36 over 2. So 36 over 2, which is 18, plus 5. Plus 5. Negative 9 plus 18 is 9, plus 5. Negative 9 plus 18 is 9, and 9 plus 5 is 14. And we should be careful here and make sure we add on the units. 14 feet. And so 14 feet is the maximum height attained by the ball. Just to recap what we did, we determined that the maximum height for this parabola would be at its vertex, since the parabola opens downward. We first needed to find the x-coordinate for the vertex, and the x-coordinate for the vertex is equal to minus b over 2a, where b and a come from the general form of a parabola. So we found out what the x-coordinate was. We determined that it was 3 over 2, and 3 over 2 was the time at which the ball attained its maximum height. So we plugged in that value into our equation for h of t, and we determined that the maximum height the ball attains is 14 feet. Alright, now let's move on to part 2. Find the time at which the ball reaches the ground. Well, when the ball reaches the ground, the height, h, should be equal to 0. Now, when we look at our graph, there's 2 points at which h is equal to 0. One is this point right here, where time is positive, and one where time is negative. Now, time can't be negative, so we're just going to disregard that second point. So essentially what we're looking for is the time at which the graph passes through the x-axis. So in other words, we're looking for the x-intercept. Well, to find the x-intercept, we just take our equation h of t and set it equal to 0. So we have negative 4t squared plus 12t plus 5 equals 0. But how can we solve this equation? Well, of course, since it's a quadratic equation, we can use the quadratic formula to solve for the values of t where h of t is equal to 0. Based on the quadratic formula, we know the values of t where h of t will be equal to 0 is minus b plus or minus the square root of b squared minus 4ac over 2a. Once again, b, a, and c in this formula are based off the general form of a quadratic equation, which is y is equal to ax squared plus bx plus c. In part A, we established that b was the coefficient of t, so 12, the square root of b squared, so 12 squared, which is 144, minus 4 times a, which is negative 4, times c, which is 5, all over 2 times a, which is negative 4. And if we simplify this a little bit, we get negative 12 plus or minus the square root of 144 minus 4 times negative 4, which is negative 16, times 5, which is negative 80, so minus negative 80 is just plus 80, over 2 times negative 4, which is negative 8. What we have here is negative 12 plus or minus the square root of 144 plus 80, which is 224, over negative 8. Now, it turns out here we can actually ignore the plus in the plus or minus because negative 12 plus root 224 gives us a positive number, and a positive number over negative 8 would give us a negative value for time. And that negative value for time is this x-intercept right here, and we already said we would ignore that because time can't be negative. So instead, we're just going to focus on the minus in the plus or minus, and if we just bring this over for the sake of space, we get that the time at which the ball reaches the ground is equal to negative 12 minus root 224 over negative 8. Unfortunately, the square root of 224 isn't a very nice number, so we're just going to use a calculator to simplify the rest, and we get that the time at which the ball reaches the ground, which once again is this pink dot right here on our graph, is 3.37 seconds. And so there's part B. Alright, now let's move on to the final part of the problem, part C. Find the time, or times at which the ball reaches a height of 10 feet. Well, this is sort of similar to part B. In part B, we're looking for the times at which h of t was equal to 0, but in this problem, we're looking for the times at which h of t is equal to 10. Well, we can start with the same sort of process. We know that h of t is negative 4t squared plus 12t plus 5, and we're looking for when that equation is equal to 10. So what we can do here is just subtract 10 on both sides, so we end up with 0 on this side. So if we do that, we get minus 4t squared plus 12t plus 5 minus 10, which is minus 5, equals 10 minus 10, which is 0. So now we find ourselves in a very similar situation as in part B. Now you could just use the quadratic formula here to find out for what values of t the equation will be equal to 0, but the quadratic formula can get a little tedious, so here's an alternate approach you can take. Some of these quadratic equations you'll be able to factor really easily, and once you have them in factored form, finding the x-intercepts, which is what we're looking for here, becomes very easy. Now unfortunately, this equation isn't particularly easy to factor just by looking at, but I just want to show you the process you would use if the equation given was easily factorable. So if you factor the left side of the equation, you get 2t minus 5 times 1 minus 2t, and this is equal to 0. And when looking at the equation in this format, it's much easier to find out what the x-intercepts are. The equation will be 0 either when 2t minus 5 is equal to 0, which is when 2t equals 5, which is when t is equal to 2.5, or the equation is equal to 0 when 1 equals 2t, which is when t equals 0.5. And once again, we should just keep units in mind. These times are in seconds. And so here are the two time values. And so here are the two times when the ball reaches a height of 10 feet. Just to recap, we wanted to find out when h of t is equal to 10. So we moved the 10 to the left-hand side, and we got this equation. Some equations are easily factorable, and for those equations, it's a lot faster to find the x-intercepts than it is using the quadratic. And so that's why I want to show you this example. This equation is a little bit more difficult to factor, but when you do factor it, you get 2t minus 5 times 1 minus 2t equals 0. When you factor the equation, you get 2t minus 5 times 1 minus 2t equals 0. And this equation is equal to 0 when 2t minus 5 is equal to 0, which is at 2.5 seconds, or when 1 minus 2t is equal to 0, which is at 0.5 seconds. And so that's all there is to part C.